Restream cooperating today? I think it is. It is, hooray, okay. Good, good. Let's see. Studio. You gonna be good? Will not be ornery. Come on, go sit down. Come on, Diggy, you gonna lay down? Come on. Where you going? Maybe I'll do some setup. Okay, let's see. I forgot I had that. I should have turned that off for a bit. Or did they move it? Separate thing. I ain't got time for that. Get out of here. guess I'll start whenever somebody actually shows up. Okay, well, maybe I'll just start. So, hello, whoever ends up watching this later. In case you were wondering about Go's concurrency stuff, let me go to where my extra stuff makes it. Make sure it's not. Oh, right. I gotta pass a counter in there, you corner, you big dummy. Okay. We literally just did this in another video. You think I would know it? Okay, so if y'all watching this, you were probably wondering about Go's concurrency capabilities. So, first thing that you'll probably want to learn about and understand is this concept called goroutines. Goroutines are a way to, in Go, have a section of code attempt to be executed just whenever the runtime can essentially work out for it to be executed. Keep in mind, this is all this code executes in concurrency, not in parallel. While they're similar, they're not exactly the same thing. I might be not really exactly saying this the right way, but the main difference between concurrency and parallelism is if two processes are running in parallel, it's basically guaranteed that they are executing at the same time. There's basically no real arguing against it. With concurrency, they may be executing at the same time, and there may be some overlap as to when they're executing, but there's no guarantee that they're executing at the same time. And also, while one is executing, one may be also executing but then get interrupted in order for some other processes to run and then resume execution. Whereas in parallelism, I'm pretty sure they have to run in like at the same time. So when you're spinning up goroutines, it's not like spinning up threads in another language like Java, for example. These, for all you know, and you have no real control as far as I know about where the goroutines are actually executed, the runtime just kind of handles all that. You could have hundreds of goroutines that are executing on the same processor, whereas when you're doing threads, you're doing threads that they are being distributed across multiple CPUs. I guess is kind of the main difference between concurrency and parallelism and how goroutines work. So now that we kind of have an understanding of what goroutines are, how do we actually start up a goroutine? Well, it's actually really simple. So you'll see here, I have this very basic program that's creating a counter, passing the counter to a function, and that function is incrementing the counter. And then I'm just printing out the counter. So if we want this counter to be executed just whenever it can get executed, is the way to put it. All you gotta do is put the go keyword in front of it, like this. Okay, that's it. Now, when this increment function call happens, it sort of gets run in the background just whenever the runtime can have it happen. But this introduces some side effects you may not exactly be aware of, and I will demonstrate that. So when this is executing sequentially, okay, the counter is being incremented once, and so the counter is at 1, right? So if we run this may show up as 1, and it might not. So if I run this, it says 0. Why is that? So when this goroutine spun up, since this is not blocking, this next line of code does not wait for this to finish. So you've kind of created this situation where it might get done before it happens, it might not. this thing is called I believe this is what you would call a race condition, where your code may have unknown behavior based on the order of when things happen. So one way to do this, to make sure that you like wait for your Go routines to finish before you proceed, is there is a package in Go called the sync package. And probably one of the most useful things in the sync package is this thing called a wait group. And what a wait group basically is basically just like a smart counter, essentially. So if I'm going to create a wait group, sync.wait group, I think it's, God, I can't spell group like this. Yeah, so when this thing is also executing, I'm going to pass in a pointer to this sync, wait group, pointer to sync.wait group, like this. And what this allowed me to do is to add to the counter that this Go routine is running, and then when this function is done, it will decrement the counter. Okay, and to do this, so I know I'm adding one Go routine into the pool that I have running. So I know I want to wait for one Go routine. So I'm gonna call wg.add one. And what this has done is added one to the like counter, which is essentially, like I said, what a wait group is. And I'm going to pass this wait group, or a pointer to it, excuse me, to this function that's being called. And now after this executes, I want to call waitGroup.done. And literally all done basically does is decrement that counter. And what we want to do is we'll call waitGroup. I think it's wait. So what wait does is, as long as that counter is not 0, wait is going to block until it becomes 0. And once it finally becomes 0, it's going to stop blocking and let the rest of the code execute. So if I run this now, we should get our counter 1 now. Okay, so it did properly wait like it was supposed to. And to demonstrate this, we can have multiples of these running. So if I'm gonna yank this and I'm gonna copy it like 5 times. Yeah. But now I need to change this, because now we have, what, 6 Go routines running? If we run this, we get 6. Now, something else that you may want to be aware of with this, in the case of where you're passing data and sharing data between Go routines like this is not the preferred way that Go tends to want you to share data like this. And I'll show you the proper way. But if you're sharing data like this, there may be some situation, not in this case, but a situation where this code is executing may do different things depending on the state of this variable. And if these are all just kind of running whenever they want and interacting with this variable whenever they want, you again may introduce unknown behavior when you didn't mean to. What up, app? How you doing, man? So one of the other things you can do for this is introduce this thing called a mutex. And what this mutex does is it essentially tells these functions, these Go routines, hey, I'm about to interact with something that we need to kind of like take turns interacting. Chilling. Now you're alright, man. I just kind of started when nobody was here anyway, so when this recording went up, it wasn't just like 20 minutes of dead air till if somebody showed up. So to do that, we're gonna have a var mutex sync dot mutex like that. So we can do that right. Okay, yeah. And I'm gonna add one more to this, which is that mutex. So we're gonna have mute which is going to be a pointer to sync.mutex. And I'm going to pass all of these a mutex. I'm assuming okay. Can Go do API? Like, are you asking if can Go interact with web APIs? Sure. Yeah, sure can. That's probably one of the better uses for it because it has a really nice package built into it for doing like HTTP stuff. So now what we want to do is, before we interact with our counter, we're going to call mutex.lock. And what lock does is it's saying, hey, I want to reserve whatever it is I'm about to do right now. And when it tries to call lock, if this mutex is already locked, it's going to sit here and wait until it becomes unlocked and it can use it. So I'm like, okay, I'm going to lock my mutex, I'm going to do my thing that's being shared, and then I'm going to do mutex.unlock so that the other routines can carry on using that same variable. Now, assuming I didn't goof super hard, which is always possible to me, run this. Okay, see, it worked fine. Now, if I goofed and say, forgot to put an unlock here, the runtime will actually panic because it'll detect a deadlock, I believe. So like if I just remove this and I run this, you're gonna see that, yeah, fatal error, all Go routines are asleep, deadlock. The Go runtime is actually smart enough to figure out when you've introduced a situation where the program basically is stuck and can't do anything. So that's an example of how to spin up Go routines. Another way you'll commonly see Go routines used is not even calling like defined functions like this, but Go has a concept that's available in a lot of other languages called anonymous functions. And anonymous functions is basically kind of like an inline function you just kind of declare, maybe assigned to a variable. Usually you just execute it on the spot. So another thing I could do that would actually eliminate the need for me to have to do this, all this like wait group, well, not the wait group, but the passing around of like pointers of wait groups and mutexes and shit, is if I'm gonna get rid of all this gobbledygook here real fast. I don't need edit. Yeah. What are you asking, app? I'm not sure what you're asking, homie. So another way to do this would be, so we have our counter, and we could just define a function inline like this. And I'm just gonna have it do counter plus plus. Now, the reason why I can do this is when you have these anonymous functions like this, they inherit the context of wherever the function is defined like this. So even though it's like, well, how is it accessing the counter when we're not passing in the counter? It kind of like consumes the context around it and makes it available within that function. So if we wanted to execute it immediately, we would just do this. And something you'll see very commonly is we're just going to do this. So basically it's saying, spin up this anonymous function in a Go routine and execute it. Like Go, I'd like to run a bot on an XMPP protocol. Can I use Go to do this? If you can find a good package to handle the protocol stuff, I don't see why you can't. You're just gonna have to probably figure it out or find an example of someone else who's already done it. So we still need to do our wait group stuff, because otherwise this will just run and, you know, not let anything finish like we were doing before. So we still gotta do wait group.add, and I'm gonna do like 5 of them. I gotta do wait group.done. Again, notice that I'm not having to pass in like a reference to the weight group, because since this anonymous function is defined here, it kind of like consumes the context of wherever it was defined in. So I'm going to yank this and copy it 4 times. Yeah, that should be 5, I think. Yeah. So this should give us the same thing, basically. Yeah, okay. So that's a very basic example about creating and running goroutines. Now, goroutines get cleaned up by the garbage collector. Oh, you mean you talking about these anonymous functions? So yeah, it technically is a closure, but because this anonymous function is defined right here, the closure kind of inherits everything from the closure it was defined in, if that makes sense. That's why, even though these functions don't appear to have, you know, how does it know what a counter is? How does it know what the weight group is? Because it inherits the closure as defined in, it actually has those references, so you can make use of them. And yeah, that's basically all there is about goroutines. Goroutines are actually fundamentally pretty simple. Goroutines get cleaned up when they return, which something you'll probably see if you see other people's code is when you want a goroutine to stop, you just do this. As soon as the function returns, the goroutine basically stops and gets cleaned up by the garbage collector. There is so I showed you how to like kind of share data between goroutines using like mutexes. But if you read the documentation about Go, that's not the recommended way they talk about sharing data between goroutines. I believe the verbiage, I believe the exact phrase they use is share data by communicating, not communicate by sharing data, or something like that. It's some other phrase like that. So that begs the question, how do goroutines communicate with each other? Well, they do that by making use of something that Go has called channels. Channels are this kind of like a pipe where one goroutine can put data into the pipe and then another goroutine can read data back out of it. And the channels are typed. So just like slices, for example, where you have a slice of strings or a slice of ints, you have a channel that has in it strings, or a channel that has ints, something like that. So I'm gonna clean all this garbage up, okay? And I'm probably gonna get rid of this too. Yeah, I'll probably do something else with this later. Bye. Later, bud. Okay. So how do we use channels? So I'm gonna have a function here. I'm just gonna call it. Maybe I'll just use the increment again. But what I'm going to do is, what do I want to do with this? It's going to take in the current counter, so counter, and it's going to take. Actually, here's a better idea. I feel like I have a good example to do this. So to make a channel, period. Channel. You use the make command, make function that you would use for like maps and slices. You say channel and then the type of the channel. So like int. Then you pass in a second argument, which is the size of the channel. And if you leave it alone, you basically get a channel with a. I'm trying to remember if the correct verbiage is capacity or size. I think it's capacity. Capacity of 1. And that capacity is actually important. Because I'll show you here real quick. So I don't even need to use channels, I don't need to use goroutines for this example. So I'm going to have a channel here that has ints, okay? And I'm going to have my counter, var counter int. So let's say I want to, whatever this current counter is, actually I'm gonna initialize this counter. Counter equals 5. Let's say I want to put to this counter data into this channel. Well, you do that by referencing the name of the channel like this, and then you use this little arrow syntax like this, and we say counter. So what this is saying is take the variable counter and basically put it in the channel. And then we want to read it back out, right? So we're going to say response equals, and then to read out of a channel, you use the same arrow syntax, but you use it on the left-hand side. So like this, channel, like that. And then let's say I want to print this out. So we're going to say response. Now we're going to run into an issue here when I execute this, and you're going to see why. So if I run this, it says it was in deadlock. Why is it in deadlock? So when you have a channel that only has no capacity, so a capacity of 1, when you try to, excuse me, it has a capacity of 0, I shouldn't say. When you try to put data into the channel when it has no capacity, it will block until there is something else on the other side that is also saying, hey, I am ready to read data out of the channel. So the reason why this is deadlocking is because, so we get to here and we say, okay, I want to put data in this channel. But because we haven't got here yet to actually read the data back out, this is blocking, and then we're just kind of stuck here. Okay. So the way to fix this is we would need to have maybe have this spun up in a Go routine. So maybe if I do I'm gonna do go func and then kind of wrap this in a Go routine like this. And then do this. And now see, this is fine, and we'll actually get a response because when this happens right here, this will block until it gets data out of the channel. So while it may look like this would maybe block, like deadlock, or not actually let it finish, and we'd have a response of 0 basically, this will actually work. So if I run this, we get our response of 5. It did successfully put data in this side of the channel and then read it back out. Now we can also get around this problem if we actually give the channel some kind of capacity. So if I say, oh, this has a capacity of 8, I don't need to do this now, because when the channel actually has capacity, the only time that this will block is if the channel becomes full. And this is why when you don't declare a capacity, that putting any data in there blocks, because the capacity is 0. This is the terminology for this is called it's called a buffered channel. You basically have a channel that has a buffer, a queue, if you will, of that you can put data into and then have data read back out of it. So now if we run this should be fine. Yeah, because this will still block until it can read data out of it. What's another good example to do with this? So you can close channels if you don't need them anymore. And all you have to do that is you just do close channel. That's all you gotta do. Now, I believe when channels go out of scope, I think they get cleaned up anyway if no one else is using it. So sometimes you won't see this being used because it just kind of happens anyway. But I also see a lot of people who will explicitly close channels when they're done with them. And a thing to keep in mind with this is if you have 2 routines and one is sending data out of it. One is sending data into the channel, and one's reading data back out. If you're going to manually close the channel, you should only close it from the sending side, because these whole things with channels and stuff, they're also kind of fragile. And if you try to send data, put data into a channel that's already closed, the runtime will panic. Like, I don't really think you can do anything about that. It's gonna panic. To demonstrate that, if I move this up here, for example, and I run this is gonna panic. Panic, send on closed channel. So this is why if you're going to close channels, you only close them on the sending side. Something else to keep in mind about channels, and this will become more relevant later, is when you read data out of a channel like this, it actually returns two variables, not dissimilar from whenever you try to access the key from a map. And the second variable is actually a Boolean, which is, I guess you will call it done. I was called done. Or, no, I'll just closed. I guess I'll put closed. Because what the second variable basically is telling us whether this channel has been closed. So if I demonstrate, I'm gonna demonstrate that by, I'm gonna get rid of, actually I'm gonna do it, let's do this. So if I do this, I'm gonna say if closed, if closed, fmt print line, the channel is closed, else fmt print line, the channel is open. So if I, oops, I need to, oh, that's fine. If I run this now, use of built-in close, oh, whoops, I've, you big dummy. There, closed. You'll see it says, the channel's closed. Oh, wait, I'm sorry. I got this backwards. It's, I think I got this right. Hold on, is the channel's closed? Maybe it's not if it's closed. If it's open, it's open. I'm dumb. I got it backwards. It's if the channel is still open. So, open. I guess, yeah, that'd be a way to put it. If not open. That's the better way. That's the correct vernacular, excuse me. Yeah, see, the channel is open. Now, if I put this close call here and then do this, now it should go to the other side and say the channel is, it's closed. Oh, or maybe I'm completely wrong about that. Did I make a derp? I might have made a derp. Oh. I haven't done this for a while, so maybe I just didn't do that right. Channels. Now I gotta double check, because I thought that's how that worked. So I'm just being a derp. Over here. Oh, that's right. I'm sorry. Okay, I'm sorry. I forgot about that part. So the second variable, the Boolean, will return false if the channel is closed and there's no more values to read out of it. But because we do this, right, it was actually closed, or like we still read a value out, so it's still true. That's right. I'm derpy. I would have to try and read out this twice. Yeah, I think I have to read out it twice. I have to do like this. Might I don't remember if this will occur. So if I try to do, I'm gonna leave that there and then do like the same thing up here. So you would think this blocks. And if the channel was still open, it would still block. But I believe, unless I'm being derpy again, this should be fine. Yeah, okay, so when you try to read from a channel that's closed, it doesn't block. It just moves on. And you'll notice that this time we got whether the channel was this was false this time, because now the channel is closed and there were no values to read out of it. Okay, I got it right that time. Hooray! Okay, so that's fine and dandy, but let's actually have a practical example of this being used. So let me get rid of all this gunk here. I'm actually going to show you a trick that you'll probably see get used sometimes, and that is there is this technique you can use to tell goroutines to basically stop if they're kind of just running indefinitely. So to demonstrate that, I'm going to have two anonymous functions here, and they're just going to have an infinite for loop. They're going to have some ints inside of it, var I int. Or hold on, let me do this outside. Did it wrong. Var I int. Var I. So we're gonna do I plus plus fmt print line go routine 1 I. And actually execute it. It's acting like it doesn't like that. I'm not sure. Oh, no, it's fine. Okay, it's my syntax. How I'm being dumb. Wow, what a shocker. That's never happened before. Yeah. So let me copy this and have it down here too. I'm gonna say go routine 2. And I'm gonna put some sleeps here to kind of simulate that this is taking a while. So I'm gonna do what is a time.sleep, and I'm gonna have this one sleep for time.second divided by 2, so a half second. And then this one's gonna go every second. So there's like some kind of difference going on. So if we just run this as is, oops. Oh yeah, I need to actually make this wait, don't I? We're going to, let me get my wait group back. Wait group, sync.wait group. Let's see, wait group dot add 2. And wait group dot done. And wait group dot done. Unreachable. It is unreachable code, isn't it? Though. Oh wait, I know a workaround for this. I think there's another thing you might see sometimes. Let me get rid of this. If I just do what is that called? There's something where you wait for input. Wait input. I forgot what this is called. I even did like a even did a tutorial about this like a super long time ago. You think I remember what the hell it is? Is that really what that is? That doesn't sound right. Wait. It's gotta be what I'm. I let my brains take a crap right now. You'd think I remember this. And you would be wrong. I guess I do want to scan. Do I want to scan? I guess that works. Okay. And I guess I could just, new scanner. Like that should wait. That wait. Yeah. Okay. So you see the Go routines running, right? This, and it'll, you know, I'll interrupt it myself. So let's say we want these Go routines to be done after a certain amount of time. Well, we can do that by basically giving them a channel that they want to try to read out of. And what'll happen is when that channel is closed, it will allow it to basically just tell it to stop, basically. I think this is a good example. I think this is a good example, or if I'm being dumb. Am I going to have to reference my own video? I might have to. You think I would remember this? Okay, you know what? I got a better idea. We're wanting to demonstrate two Go routines like passing data around, right? So let's do something more along the lines like of some kind of pipeline. That probably makes more sense. So I'm going to get rid of all this garbage. Let me check. I'm gonna laugh if I actually have like, I don't remember if I actually uploaded a repository with code for this one. So I don't think I started until 8. No, I don't think I did. Oh, okay. When you don't even remember off the top of your head how to do this shit. Oh, the dread. There's like a specific example I wanted to do for this, and my brain is just farting super hard. I think this will beat my own video. Show me myself. What was this thing I was trying to do? Is it bad when I like don't remember what my own thing was for this? Oh yeah, actually that's probably a good example. So actually let me, before I get on to that, I just remembered something. So you saw me reading like a single piece of data out of a channel, right? So what happened? It will get very monotonous to constantly like sit there and keep reading data one at a time like that. Well, you could actually use the same range keyword that you use on like slices and maps on channels, and this is actually really convenient because it will automatically stop when the channel closes, specifically, not when it's just out of data. When it's out of data, I think it just kind of sets there. So to demonstrate that, I think I just use the same damn example I used before, actually. Yeah, sure, I'll use the same example basically. So we'll do we'll run a process, and the process is gonna add it's gonna basically take an int and just add some kind of value to that int and then write it back out. So I'm gonna have input is an int and mod is an int, I guess is the way I put it, and then we're gonna have out is a channel int, like this. And all I'm going to do is take the input, modify it with the... No wait, that's dumb. Why am I doing it? That's dumb. What am I doing? Stop it. I can just do like counts. I'll just do this. Holy shit, I'm doing this way too hard. Give me my channel of ints, please. Okay, yes. And I'm just gonna loop over and just basically spit out like 10 values to channel. So I'm gonna say for I equal 1, I is less than equal to 10, I plus plus. Time dot sleep. So I'm going to like indicate that there's kind of like some processing time. Time dot second divided by 2, and I'm going to send this out to the channel, which would be I, right? And after we're done, I'm going to close the channel, indicate that it is done. Okay, so I'm going to make our outbound channel of ints, and you notice I'm not giving it a size, so it's unbuffered is the term. Now I'm gonna do go count, passing in my channel, and I'm gonna do for b like value equals range over out. And I'm gonna do fmt.println message from count b. And this should basically range over this until it's closed without us having to specifically tell it to do that. So if I run this, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dead. Okay. So that's how you would read, like, continuously read data out of a channel until it's closed. You don't even have to double check to see if it's closed that way. Now, here's probably the better example that I probably should have shown you, which is I'm gonna have like a simple pipeline of channels. Basically, one's gonna send data to the next one. Excuse me. So I am going to have this outbound channel, right? But instead of reading the value out like this, excuse me, I'm going to actually pipe this to another goroutine and have it do something with it. In fact, I think maybe I will have it take that integer and, I don't know, basically apply some kind of modifier to all of them. So I have my outbound channel, and I have my, I'm passing into my count. So I'm gonna have another thing here called mod. And this is gonna take a input channel of int, and it's going to have an outbound channel of int. Now, something to note with when you're passing channels in as arguments like this is you can actually be very specific about what type of channel it is. And let's say, so this is, we're writing data into this channel. So we can do this. This means that this is a write-only channel. This is the write-only side of a channel. This prevents us from, say, accidentally trying to like read data out of it. In fact, you can make channels, I think, specifically like that, but usually you just make like the base channel and you say like, give one function the read in and one another function the write in, something like that. Is that fucking Grinder? Bro, where you been? You like disappeared off the face of the planet. I'm starting to wonder what happened to you. Dealing with a lot of stuff. Well, that sucks, man. I hope it's going all right. Hope you're dealing with it. So what was I doing? So, right, yeah, we got this part. Then we're gonna pass in. So about these arguments. So this is our input. So we're reading data out of this one, right? So I'm gonna put this reading. This is the read-only side of a channel, and then again we're gonna have the write-only side like this. I'm coping, just trying to figure shit out. I hear you, man. Me and my wife are trying to figure shit out too. Not with each other, just, you know, with the situation in general. Yeah, if you're popping in here for games, the games run whole for a little bit. I decided to try to repurpose my stream for something that was, I guess I thought would be more valuable to people. I could like teach them stuff, like teach them coding and stuff. Not even like live coding. Like I think live coding is fucking boring as shit. But for me to sit here and be like, okay, I'm going to like teach people live how to do things. Yeah. Lost Wi-Fi at my place and lost my chance at my job, and now I popped in because I haven't watched in a while. I missed you honestly. Oh, bro, that sucks ass. Did you lose your chance at your job because of your Wi-Fi dropping out? Wait, I also need the, what is the modifier? So I'm gonna say, modifier, modifier, okay. Yeah, we'll do that. Yep, they called me while I lost Wi-Fi and I called back on someone else. Already got the spot. That fucking sucks, dude. Actually, wait, what would you not having Wi-Fi have anything to do with you not being called? Do you have like one of those Wi-Fi cell phones? Maybe sure I get myself. So we got mod. I have a text app basically right now because I haven't had my phone. I haven't. Okay, I got you. Okay, that makes sense. Okay, so I need a second outbound channel is what I need, yeah. Make channel int. So for this one, I'm gonna do mod. I'm gonna pass in the out channel as the input, out2 as the thing that I'm gonna read data out of, and then the modifier, 5. right? And what I'm gonna do is, so for, I was put B again, V equals range over input. I'm going to do out, put in V plus modifier. And then after it's done, I'm going to close out. What's new in my negative was nothing much except for me trying to focus more on like the, I guess, educational aspect of what I've been doing. I had to repivot a little bit to looking for a job because, you know, kind of running up on that point. I'm trying to re-engage with unemployment. It's being a fucking nerd, yeah, I'm being a fucking nerd. Helping my wife with her trying to get more commissions and just kind of get her work out in front of more eyes. But she's actually doing a pretty decent job of herself, but I need to do some more with that anyway. It's like probably Monday if I can think of one to do. Whenever I stream, I'm probably gonna do like a more project-based stream if I can. I have to think of a good idea. I miss being on Twitch and YouTube, and that's good, man. I know that struggle with a job, but yeah. I intentionally didn't engage unemployment before because I was like, well, I don't need unemployment. Other people actually need this shit. I think I'll just hold off on it. But now I'm getting to the point where I need it, so it is what it is. So we are reading data out of our first input output channel into this function, and writing out to another channel using this modifier, and then closing that one when it's done. Okay. So instead of doing a range out of this, we're gonna do a range out of the second one, like that. And assuming I didn't bork that super hard, this should basically be the same thing as last time, but you're gonna see this basically get B plus 5. So I run this, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, hooray, it works. Yeah, so what we've done here is we have two channels, two goroutines that are essentially communicating. But they're communicating by sharing data through these channels rather than using like pointers and mutexes. But I've been gaming a lot to cope, and I beat Kingdom Hearts 3, Lollipop Chainsaw, Digimon World 1, and I beat Chrono Cross because why not? Very nice. I think the only game that I played a little bit while you were off the grid was not on stream obviously, but I was playing Frostpunk. I didn't even get Frostpunk on PC. I got Frostpunk on PlayStation because I was just kind of playing it a little bit before I would go to bed sometimes. Frostpunk is a fucking good ass game, man. Okay, back on topic. So yeah, we have two routines that are running, and we're communicating through channels to each of them some kind of data. This thing that I just demonstrated to you is actually like a pipeline, because what we have is we have our, you know, we're creating some initial data, and then we're passing that data to another channel to modify it, and then we're reading it back out. This would be kind of synonymous with say how middleware works in servers. Actually, I believe in a lot of them that is kind of how this works. I've also been working on Kingdom Hearts 1 and 2, and how far did you get in Dragoon in my disappearance? And sorry, like I never reached out, kind of just been... Oh no, man, I think I only did like one other stream maybe, past from where You dropped off the grid? I think the last thing I did was I was at the end of the ghost ship is where I stopped at. The last stream that I did with Dragoon, I stopped at the end of the ghost ship. Or what I assume is the end of the ghost ship. So let me actually demonstrate that the thing I was talking about with the like done signal thing. Did you miss my randomness? It was very noticeable. It's very noticeable when you're not in here. I can tell you that. It is extremely noticeable when you're not. I wasn't the only one that was wondering where you were either. I think, who was it? Scott and I forget who the other person was. There was like 2 other people the last time I was streaming Dragoon that was like, man, where's Grinder at? So let's say that I don't really want this to go past, like let's say I want this to stop after like 2 or something. One way to do this, and we don't even necessarily need to do this on both of them, because when this channel gets closed, this will close anyway. It'll kind of cascade. Let's say I want to be able to terminate this because it's like the entry point. I'm gonna have a channel here on the read-only side, done of Boolean. You usually see either like Boolean or like the blank interface. So I'm gonna make this channel called done. Make channel bool. And I'm gonna pass it to this. And what we're going to do is, excuse me. I also had to get. Oh, did you? Oof. You don't have it though? Good, man. I've only known one person who's gotten it, and that was my dad got it like a month ago. He's fine. Actually, him getting it and being basically totally fine the whole time kind of took a lot of the sense of urgency I might have felt about it away, because he was really like he's the walking example of somebody who doesn't want to get it. He's like 74. He has heart problems, respiratory problems. If there was somebody that you could show a card and be like, it's really bad, this person gets that thing, he got it. He was fine. He was basically in isolation for about 4 or 5 days, then ta-da, felt fine. I was like, well, shit. He did some shit. Actually, this example probably isn't a good example to do the done signal stuff. Did it because I wasn't feeling good and I was getting worried. Like, there's been like one time where I like kind of felt bad, not bad, but like I had a cough. Well, you know, because I was fucking coughing on stream. But most people who get it don't have any problems. Let's go back to. Oops, that's too much. Get rid of this. I'm gonna have a different example I think will be better for this. Let me. And it'll allow me to demonstrate the, there's a select statement, which kind of looks like a switch but it's only specifically for channels. So I'm gonna toss this out. This is still fine, I think. Yeah, this could still be fine. Okay, yeah, I had this right. Okay, so we're gonna have it done. Read side only, channel, a bool. And we're gonna have an input channel. No, wait. Oh, I'm confusing myself. I'm gonna clean this up because I'm confusing myself by having all this stuff still here. So what I basically want a couple of processes running that I need to tell it, hey, if this channel closes, stop. That's basically what I want to do. So actually, I don't think. Let me bring this back. Let me bring all this back. The mod one would be good for that. I get that. Okay. Yeah. So I'm gonna get rid of this. Yeah. This makes sense. Okay. So we're gonna have the done channel. Because this has the two things that I wanted, like I actually wanted. So instead of having a range here, we're gonna get rid of this. And I'm gonna do for an infinite loop. And I'm gonna do a select. So what a select is, it's kind of like a switch statement, but only for channels. And I'm gonna do case. I try to read out of done. And if it is done, I'm going to close out and return. Now, basically, you would think that only counts for if there's actually data in the channel, but this will actually go through too if the channel's closed. I also had to go get a test to go and complete at my local wrestling show, but didn't get my results in time, so I couldn't wrestle. That sucks, yeah. How has YouTube been going? Have you done any more cross-brand stuff or whatever you were doing before? Well, that's still a thing. I just haven't actually done the video yet because I need to make like a project-based video, which actually requires me to like plan stuff out a little bit instead of just going like, oh, what subject am I doing today, and just kind of setting my ass down and doing the video like I usually do. The channel's going all right. The channel's up to about, I think I'm at like 345 subscribers. So not explosive growth, but steady growth. So we're gonna have another case here, and that's gonna be if I can read out of the input. Or I guess I want to be what? So I'm gonna do v okay equals read out of input. And we're gonna do if not okay, close out and return. That should be what I'm. Oh, right, I gotta put the oh no. There. Otherwise, we're going to do the out, feed into v plus modifier. I still need this now. I can just can I just do defer, close on out? Yeah, no, I gotta keep doing this. It's basically when this whole thing stops, it will close this anyway. Could also do, what, break? Yeah, to break the actual for loop, I think. I'm not sure if that'll work. I'll have to check. We're gonna get rid of this. Get rid of this. n equals make channel int. I'll replace this with rid of that. I need my done channel. So done. This needs to be in my stuff. Great. Hoping I'll be back in September. You'll be back? What do you mean exactly? Like, do you not still have Wi-Fi? Or you're somewhere else? Or do you mean like back on YouTube? So now that this is running, I'm basically just going to do for I equals 1, I less than equal to 10, I plus plus, in, put in I. But assuming I didn't bork all that. Oh, I made it bork. I made it bork. Oh, let me, I guess let me buffer this channel. Oh, seriously? Why would that deadlock there? That's weird. Like Wi-Fi, hopefully we'll be back. I'll be back to doing YouTube, Twitch, and the day I get Wi-Fi back, I'm doing a stream to talk about what's been going on and all that, so no one else is concerned, so they are eased. I'm okay. That's good, man. Do you know why the Wi-Fi is out? Like, is it your provider? Did your router take your shit? What happened to it? Maybe I do need return? Maybe? Although I don't think that should matter, but I could be wrong. No? What did I do? I broke something, apparently. In. Okay, this reads in. This reads from input. That's probably still gonna not work. Same way it's not working. This isn't like different from the example I already did. For close, for infinite loop, select case done, return. Case v equals read out of input. Not okay. This is not okay. Not okay, return. Put into out e plus modifier. Okay. Is it because this isn't buffered? Maybe. Hey, okay. Jesus Christ. Because our roommate that we kicked out because she was being toxic, so we have been paying towards the Wi-Fi. When I say we, I mean the other household roommates have been paying for her Wi-Fi, and we paid for the month of August, and we gave her an ultimatum: either pay us the $100 back or let us put the Wi-Fi in the main roommate's name so we can have it, because she never put a dime into it. So when she was getting her stuff, she snagged the Wi-Fi and hasn't paid us the $100 for paying the Wi-Fi, basically. Wow, dude. Some people are just fucking scumbags, man. It's pretty sad. Yeah, that was the issue, because I was trying to put data into an unbuffered channel without there being something ready to read it out, I guess. Even though that should still count, but I've been wrong. Okay, so the whole example I wanted to demonstrate for me having the fucking dumb channel here was, so let's say halfway in, I'm just going to stop, okay? Or let's say I'm only gonna give it 5 values. And I don't close this. In fact, okay, that's fine. So you can do it 2 ways, I guess. You can either do it that way, or you can, what am I doing? So after it does this 5 times, I'm going to close done. Now if I run this, oh right, I need to actually wait on you wait dummy. Time dot second times 4. So it's gonna wait 4 seconds. Oh, whoops. You big dummy. I gotta actually close it. You big dummy. This probably isn't the best example, but yeah, I'm not actually printing a thing. Being derpy. Are you all looking for another roommate to replace her? Or are you just gonna like wing it with what you got so far? Yeah, this part wasn't a good idea either. It's hard to think of Sheldon saw. Yeah, it's bullshit how she treated us and all that. She acted like we had to kiss her feet and worship her. She was that type of person. And then she always never understood why none of us wanted to hang out with her. Oh, one of those people, huh? The most amazing sense of lack of awareness you've probably ever seen. We got it. There's 3 of us. That's good. That's good, man. So instead, let me do this. This is probably make more sense. So I'm gonna add another like anonymous go routine. I'm gonna do time.sleep of time.second times 4 and do close on done. Let's run. Alright, I was doing it here, wasn't I? Okay. Or no, wait. I should just do it here. I'm dumb. Oh. If not, time.sleep to simulate that there's some kind of process going on. Time.second times Or divided by 2, yeah, it works. Just try this. Maybe I'll get my point across. 6. Okay. Well, that's probably the dumbest way to demonstrate that, but there we go. We're basically using this channel as a signal to say, hey, you're not getting anything else, stop. That probably makes more sense if it was orchestrated a little different, but okay. My video was probably a better example of that than what I just did. Because I thought about that one before I actually made the video. Yeah, her roommate is her sister, and she's the younger one who is the main householder, and she never ever appreciated us helping her, and never appreciated anything we tried to do to help her, even though she was a cunt to all of us. Oh, dude. That's so good, though, that she's gone. People like that are so exhausting to be around. I think I showed this in a video. Maybe I could do it here too, but I might just make it a big mess like I've been doing with that other stuff. There's a pattern. No, there's a couple of patterns you can do with this. These whole things with like goroutines and channels. One of them is called fan in, and that one's called fan out. So with fan in, you're having multiple goroutines write data to the same channel, and you're having one goroutine basically read all of that data back out. So let me see if I can set up something to sort of demonstrate that. Let me get rid of all this stuff. There we go. The main householder told me and her we needed to look for a job, and as long as we put in effort, we were fine. I tried, and she never did. Ugh. Oh well, bitch is gone. The Wi-Fi part is very annoying and very disruptive, but at the same time, it's like time to pop open the fucking cold ones, man. The fucking bitch is gone. Okay, so I want to do fan in, right? Yes, okay. So I'm gonna have two functions here. Each one is going to basically continuously put a certain string into a channel. You could simulate it as being like, whether it's like orders or, yeah, taking orders for like certain items or something. So I'm gonna have func called make orders. It takes in a item that's a string. It has a outbound channel. So channel right into string. It's going to let's see. It's going to for I equals 0 or 0. I is less than or equal to 5. I plus plus. It's going to do into out. It's going to write order I why is that complaining? Very bad. Cannot convert order. Not vert order untyped string constant to int. What means an int? What the hell are you talking about? Oh, I'm dumb. That's not how that works, Donnie. fmt sprintf order %d %s item. Yeah, that makes sense. Okay. Yeah, it just sucks because technically she cost me my chance at a job. Yes, she did. I've been just annoyed, you know, with not working or even being able to do YouTube or Twitch because I missed it and was getting my groove and I was getting somewhere slowly with it. I also miss being a mod for you and my other friends' streams. Well, I'm glad to have you back, man. I can wholeheartedly say that my streams are certainly much more lively with you being. Let's see. So what this will do? What this will do is run a loop and kind of print out like 5 orders of some item. So what I'm going to do is I'm going to create this outbound channel, and I'm just going to feed all 3 of these goroutines this channel. Okay, I'm gonna have out equals make channel string, and I'm gonna run this make orders like with 3 of them. Yeah, that'll work. And I could technically spin up a whole separate goroutine to read them out to, but technically speaking, the main function, like the main line of execution, is technically its own routine. So what our main routine is going to be the end part of the fan in. So we're going to have go make orders shoes, pass in out, go make orders webcam out, go make orders I can't spell dude, make orders, there we go. Cell phone out. See, you and the other guy who I'm off for said the same thing, which bothers me because if you are subscribed or follow and you're not there to support, it's kind of pointless. Like, I try to watch everyone I follow or sub to or be there somehow and support, and with Twitch it's meant these conversations. That's true. I wouldn't say I try to be around for everyone that I follow, because I follow a lot of people. Now keep in mind, I would probably say most of the people that I follow, I don't actually even watch them anymore, probably because they play a game I don't actually watch anymore. Like really, there's only like I don't actually watch Twitch that much. My wife does. My wife watches Twitch like all the fucking time. But when I do watch Twitch, generally speaking, I think I maybe watch Moon, and maybe if my wife shows me somebody, I'll watch them, and I'll try to watch your streams if I'm not in the middle of something. But other than that, like that's it. Like, yeah, I watch you when I get the chance, and like if I'm falling asleep, maybe I'll put like somebody's stream on, but other than that, I don't really consume Twitch content very much. Okay, so what was I doing? So make orders. So we have these 3 routines that are creating some kind of data and putting them into one channel. So our main routine is acting as the in and is going to continuously read out from all of those routines. In fact, I also need to add in like time.sleep to again simulate that there's some processing taking place. And I'm gonna do for O equals range over out fmt.println order received and O. So let's run this. Yep, oh, we're all asleep. How do they sleep? Oh, you big dummy, I didn't party. I didn't, okay, yeah, I didn't close the channel. Right. I don't want them to close either, I don't think. Because they all have their own, they all have their own copy of it. Right. This is probably where I would need a wait group, wouldn't I? Yeah, I think so. Actually, that's a good question. Alright, man, the library's Wi-Fi is being funky. I'm gonna head home. I'll see you when I'm back, hopefully soon. I'll let you know when I do that Twitch stream. Alright, man. Hope y'all get that shit figured out soon. That does deadlock that. So I have three goroutines writing data out to the same channel. And with that, he takes his leave. Later, Grinder. Didn't I do, like, I did something like this in... I hate that I keep having to reference, like, my own video that I did about this, because I feel like I should remember this already. I guess not, you big dummy. Oh, I need to use a sync group. I'm dumb. I need to use a sync group for all this. Yeah, I need to give these things a sync group, so... So what I probably should do, because this makes more sense, is I have another thing here called, I guess I'll call it process. And it has, I guess no, wait. Well, my brain's starting to shut off, man. I should have thought about this a little more if I started doing this stuff. Oh well, whatever. Oh well. If you want a better example of this, instead of me sitting here trying to make my brain shit to do this live, I have a video on YouTube. I think it's called like 3 Simple Patterns to Organize Goroutines. Basically, what I'm trying to demonstrate is there. I'm just having a very hard time doing that on the fly right now. But anyway. Alright, so I'm probably gonna dip now. Thank y'all for watching, whether it's now or watching the recording later. This one probably wasn't as useful as the intro one, because I had to kind of think about this stuff on my feet. I'm going to try to do some project-centric streams next week, if I can think of good ideas to do it with. So stay tuned for that. Y'all come on back now, and I'll see you next time.